Yo, 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 what's up? What's up, everyone? It's your boy, Johsabram. What? Johsabram. We back. We BACK back. This time. This time we're gonna do something pretty huge according to me. I'm gonna read my first research paper. Research paper? Yeah. What is that? Let's find out. Let's find out. So basically the paper is called BioXLSTM, Generative Modeling, Representation, and In-Context Learning of Biological and Chemical Sequence. Let's see. Let's see what this paper is about. Maybe I don't even get to the like I could not even scratch the surface because it's too complicated. But we gotta try, huh? We gotta try. So I'm gonna use Notebook LM to understand, to ask a few questions again. Using AI for everything, I'm not a big fan. Not gonna lie, I'm not a big fan. But there are some reference in here. Maybe I could use that too. Okay, so this is basically a research paper that I'm planning to do seminar on, and let me know how to start with this, cause I never read a research paper in my life, like not read in a way. I forgot to turn on the chat, but still, I don't know if the chat is gonna show up in fucking black. At least it could have shown up in brown. Because the background is not brown. But So, a bit context about myself. I'm a biochem student who's just entered my third sem. What are these others? Oh, it's all Gemini Notebook, okay. What is this? Since you are a biochemistry student, you already have most important foundation. The core problems. Why do we need this? Is a standard tool for AI right now. It's called transformer architecture. Transformer architecture, like Optimus Prime. You know Optimum Prime. Oh, me momo Optimum Prime. Mini Neo Optimum Prime. Oh, wait. I need to make a difference. Yo, Alexandra. Hello, Alexandra. How you doing? How you doing? What was I doing? I was doing something else. Yeah, I was doing this. I was German. Good. Good to hear that. Good to hear that. I'm guessing, Alexandria, you're watching this stream on the vertical. Yeah, you're on the vertical one. No worries, no worries. So if you're wondering what I'm doing here, basically I'm trying to read a research paper. I never read the research paper, so it's gonna take a lot of time for me to understand what these people done. But yeah, that's what I'm doing right now. And I thought, why not stream it? Why not stream? Not a big fan of the vertical stream. Like, not a big fan of saving the vertical stream. You know what? I need to make a small change on the program in a way that after the vertical stream is done, I just delete it. Because the horizontal stream is gonna include all the information that you need for this. You understand? It's called transformer architecture. While powerful transformers have quadratic runtime dependency, in simple terms, this means that if you double the length of the DNA sequence, the computer needs 4 times the power and memory to process it. Oh, okay, so the bigger the sequence, the more the time it's gonna take. Makes sense. The 3 flavor. The researchers created 3 specific versions of this model, each tailored to a different area of your studies. DNA XLSTM, that's the title. This model is trained on human genome. Human genome, like me, like my gene, like I could be part of it. A key feature here is reverse complement equivariance. Since DNA is double-stranded, the model is designed to understand that the sequence and its reverse complement are mathematically related, which means it predicts things like gene regulation or gene variance. I'm gonna need to Vanya Kandari. What's going, homies? Hey yo, how you doing, homie? How's it going, fam? I'm doing very good. Yeah. JS. Just sitting? Just, just. Is this biology? You could say it's biology, yeah. It's basically a research paper related to biology. And I never read research paper. And my brain is getting a little bit overwhelmed from the number of text in there. This version focuses on protein sequences. It is designed to capture long-range dependencies, which is crucial because in biochemistry you know that amino acids far apart in sequence can interact with what? This version focuses on protein sequence. It is designed to capture long-range dependencies, which is crucial because in biochemistry you know that amino acids far apart in in a sequence can interact when a protein folds into a 3D shape. Amino acids far apart can interact with the protein after it's okay, and can even perform in painting, filling in missing parts of the protein sequence. Okay. ChemXLSTM. This is a small molecule. This is for small molecules represented as text strings called smiles. Can generate the molecule idea for drug. Okay. Key concepts to highlight for your seminar. You should explain these three modeling approaches. Okay. Casual language modeling, masked language modeling, in context learning. How to structure your seminar. Biological context, old versus new tech. Big three, result, conclusion. A tip for your first paper, don't get bogged down in the complex math equation. Since your audience is likely other biochemists, they will be more interested in how the model handles biological data. Nah, I don't know, I'm not sure. Nicholas Roberts says he have a you have a I do have a what are you gonna do with this bottle of water? A bottle of water. A water. 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 Wasser. I don't know if it's all gonna be biochemist, but I feel like I could get asked on how the math works, so why do you look like someone that escaped her? Her is escaped her. Please chase with a dog by on you. Please chase. Whoa, Nicholas Roberts. What do you mean, though? Please chase with a dog by on you. Oh, some incredible words placed in. Nicholas Roberts, you're 15. Oh, okay. I guess that makes sense on why the sentence is a bit jumbled, but so you're saying I look like someone who escaped? Alexandria said hi. Hello, Alexandria. I think I 6 7. Okay, that's it. Don't spam. I get it. I get it. Number 6 plus 1, number 7. 6 7. I get it. That's why do we have 15,000 dog bikes on? Okay. Whoa. Dog bikes. The f is a dog bike? Ah. Why do we have 15,000 dog bikes on? Who is this we? As in people? I've seen this. Andrew said I would like to explain our. Oh, yo, Nicholas, I really want to know what you smoking. I really want to know, like, bro. It seems fun, not giving a shit what you're saying, like, just to say some random bullshit. Not gonna lie, it sounds fun. What is your edible, bro? What did you take? Or sister? You could be a bro or sister, bro or sis. I don't know. So I would not look into the math too. So let me know. Should I just start? Bro, like, you know why and acting like this today, like in your like stream that I listened to yesterday, like was amazing, bro. Were you in the yesterday stream? No way, fam. Oh, okay. I did not know that, gang. Well, I thought you were new, but okay. What was yesterday's stream about? It was about what? German. Yeah, I was learning German, and it was like a 30-minute stream. Then I had to work. I was working. I was peeling vegetables. I was cleaning dishes. I was giving out food. It was amazing. But that was my last day of work, gang. I don't have a source of income. Should I just start by reading from the first page onwards? Ow. Yes, okay, you were on the stream. Respect for checking out again. Respect. So I'm a bit confused on how to start with this paper. And look at this, we got some formulas. C1 equals F1 dot. CT minus 1. No, it was T, it's not 1. And CT equals FT dot CT minus 1 plus IT dot CT. Oh, that was easy, huh? That was easy. It's called cell state. Okay. Okay. What are these CT? What is this? Oh no. Oh no. So how do you start reading this? So Nicholas, imagine if I was Eo Young Ro. I don't know what that is. Like I would literally try to turn into. My hair looks like what, bro? What's wrong with my hair? It's growing, okay? And I'm trying to hide my forehead too. That's also a part of the hair. I would literally try to turn into a human again. Real like it's. I'm not saying like real alien at the same time. So you're glad you're human. I understand. I mean, hey, right now, from what from a human's perspective, we're like the top of the food chain, huh? So when did yesterday's stream end? Yesterday's stream ended in like 30 minutes. It was like a 30-minute stream because I had to work. I had to do my part-time job. But now they fired me. Not fire, but I stopped working there. So no more work this week or next week. That's fire. No, it's not fire. It's a mutual understanding. Reading a research paper linearly can be overwhelming. Okay, I read that. Since you're concerned about how the math works, here's the biochemistry. Understanding. Okay. How to tackle that seminar. First, reread the introduction, section 1. Where is it? Is this the introduction? Okay. So first I read the introduction and discussion, section 5. That's it's where is it? Discussion, yeah. And they will tell you the story. Like there was a form, like 2000 years ago, God was Ma. How is it relating to the previous context? Your head is like 50 times longer. 50 times longer. That's a big head. Are we talking this length? This length? No, that would be width. This 50 times, huh? 50 times to the back, front. Where are we talking 50 times? Look at figure 1. It's a visual map of the whole paper. Focus on the experimental results. Since you're a bleh, the results on the paper vary in fitness predictions. Will be impressive to your audience. Okay. Again, it's not about audience. I need to. Okay. I also have to. You live in the UK. You're the one. Yo, I'm sorry, gang. I think I forgot the name. You're the British accent one. Oh, then you came up on the stream not today. It was like day before. It was not yesterday. It was day before yesterday. Let me pull up. Was it you, Nicholas? No, that was BFD Rocky. Damn, my memory is not very good. I can feel it. I can feel my memory not memorying. Focus on the experimental. Okay, so I start with reading the introduction. 200 IQ? You or me? My IQ is like, it's not 200. It's like 2,487 or something. Yeah. Yeah. Accurate computational models for biological sequences are essential for translating data into actionable insights in modern biology. Biological sequences like DNA, RNA, proteins are central to molecular biology, genomics, drug discovery. Major projects like human genome and other have large, modeling these sequences is key. Advancing and interacting with biological systems or predicting phenotypes from genetic variants. Similar efforts all. Nicholas Roberts. What is going on? As someone with an IQ of like 2,487, I don't understand what you're saying, dog. I don't. Is it for people with IQ above 3,000? Is that the requirement to understand what you're saying? Okay, I understand. I understand that I don't have enough IQ to understand what you're saying. But hey, I really like to know what edible you took. Used for tasks like protein engineering, predicting 3D structures. Large language model have emerged as prime candidates for modeling biological sequences and serving as foundation models for molecular biology and chemistry. Large language models for biological sequences must handle long sequence and incorporate context. Incorporate context. The rise of LLMs has overview of top left. Oh, BioXLSTM is the top left one. So what do you do? Let's look at some images. So me, Okay. Okay, Nicholas Roberts, you win. I should try growing my hair. Not gonna lie. Just just but now right but I hope I could grow it in a way that my hair is long enough in the winter so I can I can keep my head warm. So that's the data modeling approach. Casual language modeling. I don't know casual language modeling. What's this one? This one's something else, okay. Human genome, okay. Casual language modeling, masked language modeling, in context language modeling, reverse complement equivariance. For natural language processing task, top right, considered modeling approaches for biological sequences, masked language modeling equivariance to reverse complementary sequence, and in context learning. Bottom left, DNA X LSTM models are trained on genomic data. DNA. Did I read DNA as data? And then fine tuned on downstream tasks. Bottom center, fraught X LSTM models. Nicholas Roberts, do you play any video games? What if Nicholas Roberts just replies saying, I'm playing one right now? Oh, fuck's sake. Protein XLSTM models are trained on casual modeling setting with a fill-in middle objective and use homologous proteins for in-context learning. Bottom right, Chem XLSTM models are trained to generate small molecules for an in-context learning setting. Chem XLSTM molecules are known for. Okay, I have to read the whole thing. Yep. Revolutionized numerous fields, including life science. Most LLMs are based on transformer architecture. Transformer architecture, which excels at predicting the next or missing token using self-attention. However, the self-attention mechanism scales quadratically with sequence length. Self-attention mechanism scales quadratically with sequence length. So the more the sequence, the self-attention mechanism scales as in making long sequence modeling computationally expensive. As a result, most biological sequence models use short context. However, biological sequences require long context windows for accurate modeling because of their important long-range interactions due to 3D folding or gene regulations in DNA. The human genome spans around 3 billion base pairs, far exceeding the context limits of transformer-based models. Furthermore, long contexts also benefits models that exploit homologous proteins. In the molecular context, for small molecules, the emergence of state space for models like S4, Mamba enables handling a longer context in biological domains. However, the recently proposed XLSTM architecture recurrent neural network has outperformed SSM and in natural language processing. For further related work, see Appendix Section A. Can I just click and go there? I can. Mm-hmm. bum. It's a glass. Oh shit. Mm-mm. Mm-mm. 189 subs. Let's go. Somebody said hi. Hello. Who is it? Nakan channel. Oh, look at that. Did you see that? That was like 4 FPS. Can I replay it? Yeah, that was 4 FPS or something. Huh. Wait, I haven't checked Twitch and Kick. Whoa, I forgot about that. Forgot about that though. Twitch. Good evening, bro. Good evening to you, friend. How you doing? Yeah, Twitch is twitching. Twitch twitching. Now kick. Kicking. Kicking. Good evening. 200 gigs. You know which music that was? Some hardcore music. The recently proposed XLSTM is a powerful architecture for sequence modeling and promising candidates for biological and chemical sequence. Oh man, I gotta work out. 30 minutes. I feel like my body is stiff. Oh. I need to get my muscles working. The recently produced the XLSTM architecture introduced enhanced memory structures and exponential gates that boost its performance, particularly in natural language modeling. Despite these enhancements over traditional LSTM, XLSTM retains the efficiency of a recurrent neutral network and can handle varying sequence lengths effectively while maintaining expressivity and scalability. These features makes XLSTM ideal for modeling DNA sequences which are inherently long and for which long-range interactions between distant parts of the sequence have been observed. Protein sequences where modeling strongly benefits from contextual information of evolutionarily related proteins. Small molecules represented as chemical sequences such as simplified molecular input line entry system. Simplified molecular input line entry system, SMILES. Genetically controlled nucleotide replication. We're coming up, babe. We're coming in, babe. Gotta make a small change. Boom. Introduce enhanced memory structures and exponential gates that boost its performance. Okay, I read that. For context learning abilities are an option to generate new molecules with desired properties or from a particular molecular domain. However, it remains unclear how to best tailor XLSTM for biological and chemical sequence and how XLSTM compares to other domain-specific LLM. It remains unclear how to best tailor. Oh, so we still don't know. We introduce DNA XLSTM, an architectural variant tailored for DNA sequence with reverse complement equivariant blocks and evaluate its performance on long context generative modeling, representation learning, and downstream tasks. Protein XLSTM, a variant of homology aware protein language modeling with in context learning for both generative modeling and in painting, which we benchmark on generative modeling conditioned per protein design and protein variant fitness prediction tasks. Benchmark on generative modeling, conditional protein design, and protein variant fitness prediction. Chem XLSTM, an architectural variant of SMILES representation. Oh, SMILES, what was it? Simplified molecular input line entry system. I like that name. I like that. Representation of small molecules for which we demonstrate ICO capability. ICO was in context learning as an overview of BioXLSTM shown in figure 1. Okay, I read the move to discussion. I did not understand a lot of the stuff that was mentioned. And look at these. What the fuck is it? What the fuck is it? Discussion. Where is discussion? It's 5. In this work, we demonstrated potential of BioXLSTM variants as a prime candidate to model biological and chemical sequences. We have provided clarity in 2 key areas: how to tailor XLSTM for biological and chemical sequences, and comparing XLSTM-based models to other domain-specific LLMs, showcasing the robust performance in DNA, protein, and chemical sequence modeling tasks despite certain limitations. DNA XLSTM showed strong performance in DNA sequence modeling, excelling in both marked and casual language tasks across different context sizes. In protein modeling, protein XLSTM proved particularly effective at handling long-range dependencies, positioning it as a promising tool for generating homologous proteins. In small molecule modeling, ChemXLSTM achieved the best FCD scores for unconditional generation and demonstrated strong ICO capabilities. Our findings underscore the potential of XLSTM as a prime candidate for foundational models in molecular biology. The models we have introduced, trained, and made available can be used, for example, generate rich learned representation for DNA sequences and homology and chemical domain conditions generation of proteins and molecules without the need for fine-tuning. Mm-hmm. Oh, damn. It's not even 1 hour. Where was I reading? Protein XLSTM proved particularly effective at handling long-range dependencies, positioning it as a promising tool for generating homologous proteins in small molecule modeling. ChemXLSTM achieved the best FCD scores for unconditional generation and demonstrated strong ICO capabilities. Our findings underscore the potential for XLSTM as a prime candidate for foundational modeling in molecular. So, XLSTM has the potential for conditional models in molecular biology. The models we have introduced, trained, and made available can be used, for example, to generate rich, learned representation of DNA sequence and homology and chemical domain conditioned generation of proteins and molecules without the need for fine-tuning. While BioXLSTM has shown strong performance across DNA, protein, and chemical sequences modeling, it has several limitations. The manual hyperparameter selection process, which is due to limited computational resources, may prevent optimal model configuration. We will explore the hyperparameter space further in the future, which might yield even better models. For DNA, the reliance on character-level tokenization might also restrict this performance and scaling to larger context sizes. Also for proteins, amino acid level tokenization without explicit structural information might limit its performance. Also proteins, amino acid level tokenization without explicit structural information might limit its performance. Amino acid level tokenization without explicit structural information. So we're talking about we don't know what specific amino acid does, or we don't know how many function this specific okay, I understand. We don't have enough information of the okay. I guess a DNA XLSTM, protein XLSTM, chem XLSTM models are currently constrained by the training dataset and their generalizability across organisms and chemical domains needs further exploration. Across other domains, the training dataset contains biases, whether it's population bias in genomic data, sequence distribution biases in new protein dataset, or chemical exploration biases in molecular dataset. These biases could influence the model's prediction and limit its generalizability in real-world applications. In line with many works, we consider the perplexity metric, for example, next token perplexity or the related cross-entropy losses as a proxy for performance on downstream tasks. However, this metric might not capture the capacities of biological and chemical language models appropriately. Future work could address these limitations by expanding the training dataset and downstream evaluation of BioXLSTM. Finally, assessing BioXLSTM performance in parameter regimes beyond The billion scale remains an open question. Ethics statement. Don't give up. No, no, no. Ethics important. Okay, ethics important. Focus on the experimental results since you're a biochemist. Okay. So let's move to 3. Experimental result. Background and notation. This architecture, this XLSTM is showing proof that it's better in predicting it's showing me how it's thinking. Oh. Ah, I was right. Okay. Fuck. Somebody said they're back. Yo, BFT Rocky. What up, bro? I remember you. The British. What? How you doing, bro? Yeah. How you doing? How you doing, fam? Damn, yesterday I got back from work and that was it. Good, thanks. Well, yeah. Yesterday I feel like you no, you were not in yesterday's one. Okay. Yeah, I was at work. I got back from work and I woke up a bit late today. I woke up at like 2 a.m., 2 p.m. That's like that's past half day. But hey, we're up. We up. We up. That's what matters. It's what important. Damn. Yeah, damn indeed. But hey, today I'm gonna continue sleeping dogs for 30 minutes. That's gonna be cool. I should schedule that one. Uh, Scaling bottleneck. Oh, most AI today uses transformer architecture. I get that. Proof and limitation versatility across modalities. The terms, bro, the fucking terms. Versatility across modalities. Versatility across modalities. Okay. In context learning, there was another term. SMILE. Simplified Molecular Input Line Entry System. Smiles. Smiles. You have no idea. You have no idea any of that means? Well, guess what? That makes two of us. I also don't know what that means. But hey, I gotta look into it because I'm planning to do a seminar on this paper. What is a seminar? Seminar is basically I read this paper, I try to understand what they did in this paper, and make a presentation on this paper. And they're gonna ask me questions. So it's gonna be hard. And BFD Rock, I'm guessing you're in school or something, bro. It makes complete sense if you don't understand. Yeah, but it's summer right now. When I was in school, I was like, yo, it's vacation time. That's cool. I can have some fun. But after joining university, I'm like, summer, I gotta study for the exams that I did not pass, or I have to apply for internships that I might have chance for, or I should look into something else that could help my studies or thesis or some shit, or or I should do some hardcore drugs. That's what summer is for. The last one is a joke, okay? Don't do drugs. No, I'm serious. Don't do it. It's not good. Yee. Yee. What was I supposed to read? So what did they say in section 5? Discussion summarizes that they proved where they still need to improve. Versatility. Oh, I read that. This demonstrates the bioexcelestium isn't just a theory, it works across genomics, and proteomics, and chemistry. In context learning, a major highlight is that these models can learn from analogy. You can show the model a few examples of specific protein family and it can start predicting. Read it again. What do you mean? This part? Filling in missing parts for that family without being completely restrained. Weak spots. As a seminar presenter, you should know the limitations they mention. The models are currently biased by the data they were trained on, and yet don't yet incorporate explicit physical 3D structural information. You said I already read, so oh, I mean, I read just two parts. I read this one, introduction, and I read, what is this? This one, discussion. Where is it? Discussion. I need to read the in between parts. And I hate it that I'm consulting with an AI to let me know what should I read. That's some dystopian shit. Like, Mr. AI, please, or Mrs. AI, please tell me what, or AI. Haha. AI, please tell me what should I read next. Oh man. I just started reading, but I'm already. Beep 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 beep. Beep 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 beep. It should be 30 minutes. What's wrong though? 7 more minutes. I should do push-ups after 7 minutes. I'm thinking making I forgot the name, boards. It was called something like boards or some shit. Pages? No, it's not pages. Freeform. Should I go get my next cup of coffee? Maybe. Maybe. Creating a freeform knowledge file is a great way to prep for a seminar. Okay, freeform. New file. Where's freeform? No, not this. Go back. Oh, I have written some stuff in here. Damn. I did not know it was like this. Ionic bond, cation, anion, covalent bond, sharing of electrons. Yeah. That's me. Gamma radiation, what did I write? Somebody said hi. Yo, that's a big name, okay? Hello. Hello. Damn. So I need to make a new file. Freeform, new one. And let's just name it Bio or just XLSTM. Yo, I'm good. Appreciate that. I'm guessing you're also doing good. What was the first sentence I was gonna say? I was gonna say my brain accidentally gave in command to say I good, you're doing guess. That's what I was gonna say, but then I just stopped. My brain stopped me from saying that abomination of a sentence. Well, I gotta say, a lot of these music are starting to get boring. Oh, what are you doing right now? So basically, I'm trying to read a research paper. It's a basically a research paper, and it's my first time reading a research paper, and you're just witnessing my struggle to understand how reading a research paper is. Yeah, I was about to read a research paper, and I was thinking, yo, why not stream? Why not stream? And here we are. I usually stream whatever I do. Or Shabala. What the fuck is Shabala? I heard this. What is this? I feel like I heard it somewhere. Shabala. Oh shit. I'm from the land of the spice, gang. Land of the spice. Ah. It's a Sanskrit term for multicolored or musical project. Interesting, okay. Shambhala, Buddhist kingdom. Yes! You got it right, gang. Your pattern recognition is on point. Good. That's how it should be. So, how do I start? So, what should I read next? I read 1 and 5, even though I Oh, freak. Wait, no, I meant nice that you're from India. Yo, again, like I said, it is good to recognize people where they're from. That's good. That is a good thing. And you guessed it right. Uh, what was I about to read? Recommend you read section 3. 3. I hate asking AI to tell me what to read, but I can't just start from the beginning, huh? No. XLSTM, long range modeling of biological and chemical sequences, introduces three XLSTM based architectural variants tailored specifically to DNA, proteins, and small molecules. For these application domains, we extend XLSTM from casual language modeling to a new modeling approaches such as filled in the middle. Okay. In context learning and past masked language modeling, casual language modeling, and next token prediction. Casual language modeling uses. Oh, you can just drop an equation like that. God damn. EX, where CE is the cross entropy loss with logits. PX is the data distribution. PX, and for inside the bracket 1 to t minus 1 is the discrete uniform distribution. Uniform distribution of what? I don't know. The objective measures how well a particular sequence token can be predicted based on the previous tokens. X1 is to t by the model XLSTM R d cross X to R d cross X. Therefore, this type of modeling is sometimes also called next token prediction, unidirectional modeling, or autoregressive modeling, and the loss is called NTP loss. Okay. Why do I feel like my eyes are bulging up? Oh, I gotta wash my eyes. Feels weird. Just a minute. Just a minute. Illuminati. I don't know what happened to my eyes, but it feels weird. Well, Shabala, it's a good thing that I knew this night. I now know this term, Shabala. So it's basically art, musical art type shit. Oh no, we got. Oh no, that does not look good. Shabala King Garuda, multicolored king of air, Chi Prana. Interesting. The objective measures how well a particular sequence can be predicted based on the previous tokens by model XLS. Fill in the middle. Bavarian is a modeling paradigm that integrates aspects of both CLM, casual language modeling, and MLM. Middle, oh, what the fuck is middle? Mass language modeling. Yo, Abdullah Extreme, how you doing? Yo, oh, I gotta say, it's been a while since I released a new goatee video. And I'm kind of confused. What should I release? You got some shit. You got some stuff. Ghetto of the internet, not get out. Ghetto, ghetto. Getto, ghetto. I feel like initially when I said ghetto of the internet, it sounded like get out of the internet. And I'm like, yo, that's not what I meant. RKV, yo. எப்படி இருக்கு மச்சான்? Parts of sequence are replaced with a mass token, which are then appended to the end of the sequence. This allows the model to utilize the entire context to predict the masked tokens while maintaining an AR training framework. நல்லா இருக்கே அண்ணா. Respect. This allows the model to utilize the entire context to predict the mass tokens while maintaining an AR training framework. This strategy allows the models to perform generative modeling in painting with CLM. I don't understand. In-context learning is a capability of language models to learn and perform tasks by leveraging additional information provided as a contextual input without updating their parameters. This approach allows models to learn from analogy, drawing insights from patterns in the context to adapt to their behavior. When the contextual input sequence is denoted as Z belongs to R, D cross S. Cindy, hi. Hello, Cindy. And the conventional input sequence is denoted as X belongs to R, D cross T. Then with an ICL model, we obtain y dash equals x LSTM z x s plus 1 s plus t. Yo, you can't just write random shit and say that's an equation. Where zx indicates concatenation. Ooh, what is that term? Concatenation? Concatenation? That's a new word. It's been a long time. Linking things together in a chain or series. Concatenation. Pronunciation. How do you pronounce that? Cindy P9 said hi. Hello, Cindy P9. How you doing? Concatenation. Yo. What do you mean? You should do the emotional damage. Emotional damage. I mean, that's already there, but I could react to it. I've seen it though. എന്നെ ഓർമ്മയുണ്ടോ മച്ചു? പിന്നല്ല. Good, and you? I'm also doing pretty good. Here yo, Weibo, how you doing? Yeah, I'm doing good. Food culture, yes, food culture. Food culture machu. Yeah. What was I saying? Yeah, I'm doing good, but I woke up at 2 a.m., 2 p.m., which I'm not proud of. And the couch machu. I ate rice, fish, no, rice, rice, eggs, beef. That's what I ate. What is this? What's my favorite food? Yo, you can't just ask me something like that. What is this? This is basically a research paper I'm trying to read. It's my first time reading a research paper. And yeah, looks like I have a long way to go. Basically, I have to read this research paper and do a seminar on it. Uh, so I have to do a presentation on this research paper. That's basically. Just a minute. Just a minute. Oh, come on. Ads. You fucking kidding me? Ads. YouTube ads, YouTube. I know you want to make some money, but come on. Which type of egg, Machu? It's the chicken's egg. My favorite food is Thai cake. Damn. You felt good, huh? You felt good when you said that, huh? Well, what's my favorite food? I haven't answered that question, right? As a Malayali, I gotta say porota beef. That shit's good, but it's been a long time since I had it. Long time, like 3 or 4 years. What is the time in there? The time is 4:48. Oh, it's scrabbled egg, like toren. In my place, it's called toren, morta toren. Just it's like fried rice. Yeah, basically fried rice with beef. That's what I ate. Don't grunt like that. Poached egg. What is poached egg? It's like boiled eggs. What is poached egg? Yo, I'm not ignoring you. I was just saying. Like I would. Oh nah, bro. Tora enna topic, bro. Yeah, I was reading a research paper, gang. I also call Toran. Okay, because I heard some places they call it something else. Yeah, no, no, that's not for me. I already hate the smell of eggs in general. Like boiled eggs, especially when you work in a restaurant. They have, it's good for protein and shit. Abdullah Extreme says truth or dare. Yo. I'm gonna say truth. Okay, so basically, if you work in a restaurant, they have this boiled eggs on a container, and you should that container smells fucking whoa. So poached eggs, not for me. No, no, Mimi. Maybe Gordon Ramsay's gonna be like, oh, what was that? Yeah, it's not for me. Oh, I was confused about a word. Con continue. Oh, concatenation. Oh, concatenation. I was going for con. It's concatenation. Okay. So basically, the word means it means concatenation means linking things together. Porota beef, yeah. Porota beef is crazy. But it's been a long time. If it's not just porota beef, mut mutton biryani. Ooh. If the mutton is really cooked. Bro, I don't like egg yolk. I also used to, when I was a kid, I didn't like egg yolk, but now I'm like, okay, it's very okay. What knowledge were you exposed of you weren't supposed to know as a kid? What knowledge was I exposed? Damn. Makes me question a lot of stuff. What knowledge? Beef biryani, yeah, that's also really good. Oh shit. What knowledge you were exposed of? I think you don't sleep yesterday night. I slept, but it was pretty late. But hey, I'm still thinking of that question. What is the knowledge? Thinking like a philosopher. Again, I'm thinking like, when I was a kid, I was a big fan of Jurassic Park movie. But what does it have to do with any of this? No. But this won't be a accurate answer. But when I was a really small kid, can I yeah, I'll translate the question. So okay, basically what he asked me was, what type of knowledge? So ഒരു കുട്ടിയായിരിക്കുമ്പോൾ അറിയാതിരിക്കേണ്ട ഒരു കാര്യം അറിഞ്ഞു എന്ന സാഹചര്യം വരുന്ന ഒരു അറിവ് എന്താണെന്നാണ് പുള്ളി ചോദിച്ചത്. യെസ്. So again, something that I shouldn't be supposed to know. About sex? Nah. It took me a while. Oh, yeah, you could say about sex. I thought sex was something else, bro. I really thought making kids was something else. It was not what I imagined. But god damn it. Yeah, well, I was saying, when I was a really small kid, and whenever I go outside, I see people who ride two-wheelers with helmet, right? And when I was a really small kid, I thought those were a species of human beings that are born like that. I thought people who wear helmet, they don't have a face. They are born with this structure. That's how that species is living. That's how I used to think people with helmet about people with helmet. Then I realized, oh yeah, that's just people. I thought, when I was a kid, I thought, damn, that species of human beings are really cool. I wish I was also one of those. But yeah. But is that something that that I wasn't supposed to know? Nah, I don't think so. So I don't know if that's That's a quest that answered your question. How to talk Malayalam and English. Yo, just speak. Speak. Read. I guess. But so fluent. Yeah, I guess. Watch movies. Speak. Speak in a way how it makes it easier to come out of your mouth. Yeah. Bro, എത്ര മണി വരെ ലൈവ് ഉണ്ട്? I don't know, maybe 2 hours, 2 hours, 3 hours. Yeah. Fuck, I'm still thinking on that question. What is a knowledge that I wasn't supposed to know as a kid? Yo, respect Shashi Kumar for checking out the stream. Hell yeah. Gotta get the proteins. Okay, bye. Take care. Respect. Respect. What was the word? Concantation. Are you okay, bro? Yeah, I'm pretty okay. I'm still thinking, like, what is this? What is this forbidden knowledge that I knew? There should be at least one forbidden knowledge that I knew, that I got to know as a kid. God damn it. About the president? Nah. About government? No. About vehicles? No. Animals? No. God? No. I was really curious how phones worked back in the day, but like, that was not like I knew something about it. Yo, it's like what's the term when you ask AI a question? It's Abdullah Extreme just put a prompt that just frying my brain. Like I can't think of what. Fuck. Then where do you get these questions, bro? The fuck you doing with these questions, bro? Indicates concentrate concantation. Concantation. Concatate. No, I forgot the pronunciation. Concatenation. Concatenation. Okay, so cat. So it's a cat. Concatenation. What else? Of contextual, and conventional inputs and subscripts indicates that the last output tokens are selected for natural language processing tasks. The context Z often contains a solution to similar problems or exemplary solutions that guide the input and inform the model. For biological and chemical sequences, the context Z could represent similar genetic regions, homologous proteins, or molecules with desired properties, enabling the model to make informed predictions or generate outputs based on these analog wait analogies. Yeah, it's analogies. Okay. Sorry, bro, I left the live. Yo, the fact that you checked out, respect, gang. It should be 30 minutes already. It is already 30. How did I miss an alarm? Okay, it's time to do some hardcore exercise. Bro, in India, some people and politicians say don't eat beef, but India is the top beef exporter. Yeah, I don't know about top, but I heard they got exporters, so I don't know. Oh, I need to increase my breathing gain. $15. Mass. Okay, first let's start with 3.1. I didn't understand stuff including the equation and the parameters used in the equation. Concatenation of contextual and conventional inputs and subscripts indicates the last output token are selected. For natural language processing tasks, the context Z often contains a solution to be a similar problem or exemplary solution that guide the input and inform the model. For biological and chemical sequences, the context Z could represent similar genetic regions, homologous proteins, or molecules with the desired properties, enabling the model to make informed predictions or generate inputs based on the analogies. Focuses on casual language modeling, which is essentially the learning objective. Breaking down equation 17, CLM loss. BFT Rocky said, "Hoi, hoi, oi, bruv. I should stop this stupid." I mean, I'm not even doing the accent. Like, come on. But hey, BFT Rocky, how you doing? You playing any video? You got games on your phone? I was scrolling YouTube lives. Yo, when you said YouTube live stream, I got my next plan for goatee. It's YouTube live stream. Cause YouTube live stream is a weird place. Oh, like, oh, I can't scroll further. Come on, you should let me. You should let me scroll further. Yeah, there we go. This is mine. Someone else. Someone else. Someone else. These are all live. These are all real world people just sitting somewhere with a camera and just talking. God damn. Like, it always amazes me that these are real people. Look at this. So yeah, that's crazy. Look at this. Just an old woman doing her laundry. Oh, what did the comment say? I came across this channel when I searched for hot videos. Yo. I came across someone really corny saying this is an open family place. Open family place? What? I came across someone really corny saying this is an open family place. YouTube in general? Like iShowSpeed. iShowSpeed does live streams, yes. Believe me, bro, stop these vertical lives. You know what? It's a good idea, but I'm also thinking I will do the vertical live, but I will delete the video after stream ends. Then someone said, remember in high school when we pooped on the walls or something. Or something. They thought it was me and banned me. Yo. BFD Rocky. I gotta say, it's not always good to reveal yourself in the internet. But yeah, Vaibhav, I think one thing you said was correct. I should stop uploading this live stream, especially the vertical, because it's family friendly love. I don't get the context. Like, okay, okay. Now it's connecting. Now my neurons are like, okay. Okay. So someone revealed their stupid ass past, and the live stream, or the person who runs the live stream, banned you because they thought you said it. Okay. Yeah, I mean, come on, man. Yes, okay. LCLM. This is the total casual language modeling loss. It is the final penalty score the model receives during training. The symbol stands for expected value or average. It tells you that we aren't just looking at single guesses, but the average of the model's errors over thousands of different sequences. This means we're pulling a random sequence from the massive biological data distribution, such as the entire human genome. This indicates the time, step, or position. It tells you the model to pick a random starting point in a sequence, anywhere from first letter to the second to the last letter, and try to guess what comes next. Again, you're just writing these stuff. Like, I need to see an example to understand how these numbers perform. This represents the model's represents the model's prediction. It is what the XLSTM thinks the next letter should be based on the letters it has seen from the beginning up to the current point. Key concepts to remember for your seminar. Okay, but like you said, Vaibhav, I'm gonna make a small change in which, after the live stream is done, the vertical stream is gonna just disappear. Because I feel like, why should I waste YouTube space like this? Make sense? Because both the vertical and horizontal one is streaming the same thing. Maybe the horizontal one has more content. Content as in a little bit more screen. Paimon. Genshin, really? Behave, values. What are the data sets these terms are formed using? Like, can I get an example? Or at least how this example is gonna run a model. I just can't visualize it. Visual. Infographic. What is infographic? A visual tool that combines images, charts, and a short text to explain the complex information quickly and clearly. Okay. To help you visualize equation 17 based on the massive biological data distribution refers to a specific library the model is studying. In paper, there are three main libraries: human genome reference, the letters ATCG, yeah, protein, open protein set, letters are 20 standard amino acids, chemistry dataset, a database of small molecules, the letters smiles like carbon, oxygen, used to describe chemical structures. A concrete example: reading DNA. Imagine the model is training on a tiny piece of DNA sequence from human genome. The sequence length 5. Goal: predict the next letter of each step. How the equation turns into a number. At each step, the model doesn't just name one letter, it outputs a probability distribution. Okay? I understood the probability distribution part. I kinda get it. Yeah, these research papers are available online. And not just this one, like every university should have their own research papers published. And if they don't, that's illegal. You gotta publish these papers. You can't just gatekeep research. This is a single final number. During training, the computer's only job is to change the model's internal settings to make this final number as small as possible. Cross entropy. This math tool looks at the distribution and penalizes the model. If the real letter was t and the model gave t a 5% chance, The penalty loss is high. It gave t. If it gave the penalty loss is low. Okay, okay. The equation averages. Oh, did I slip again? Averages. Okay, I gotta do plank. What is the name of the plank that I was doing? Alternating plank? Other name. T-plank. Rotating plank. Well, planks. Plank it is. Okay. One minute. Oh. 1 minute plank, not that big of a deal, but I need to improve the numbers. The equation averages these penalties across all steps and sequences in the genome. Okay. Okay, can you show me how each term is gonna show up based on a small example? Also show how the equation changes according to each example. Also make that shows how the terms are interdependent to each other. Rotating plank, okay. I thought there was a cooler name for this. Side plank, yeah, that's, no, side plank is different. You're having trouble? Well, that's it for me. If my AI is having trouble, I guess the stream is gonna end right here. I don't know what happened, but something bit me, and it's weird. To help you visualize how equation 17 works, let's use a tiny concrete example from DNA sequence. This will show you exactly where each variable lives. The data set, data, PFX, imagine your entire genome is just 3 sequences. That's 4. Our specific sequence, we pick 1. That's 4. Sequence length, 4 tokens. What this model has read so far. Truth, what the model is supposed to guess next. The model reads the sequence step by step. The equation averages the mistake it makes at each step. Run t equals 1. Equation part CE. Equation part CE 1. Okay, 1:1. Oh, that's okay. Input A. Input X 1:1. Where is 1:1? Okay, that's the input. Okay. Model predictions. The model looks at A and output probabilities. A 5%, T 80%, G 10%. How did it come up with the predictions? So are these predictions just set, or it's by reading the data set that it was given? Like here, ATGC. Ground truth, X2, T. Where's X2? It's not even here. The result CE. Since the model gave T a high probability, the penalty loss is very low. Oh, that's... T equals 2, equation part. Now it changed. Okay. The result CE, correct guess, penalty is low. How the terms are interdependent, context versus prediction. The prediction at step T is strictly dependent on the prefix X1T. In the example above, notice how model's brain changes its guess as it sees more sequences. If you change the input AT to AC, the prediction for the next letter will change completely. Time, step versus target. The variable T time acts as a sliding window. As T increases, the ground truth moves 1 letter to the right. That's why it's called the next token prediction. Penalty versus improvement. The cross entropy loss is the link between the model's guess and actual biology. Cross entropy loss. If the model makes a bad biochemical guess, example predicting a stop codon in the middle of a functional gene, the CE term spikes. The training process then forces the model to adjust its internal math to prevent the specific spike in the future. Okay. Final aggregation. Fuck. Expected value. Symbols means that the computer takes all the individual penalties from step 1 to 3, 1, 2, and 3, and calculates one average score. Okay. Should I eat? I feel like I should. Yeah. I should eat something. And then I'll continue on. I really need to know this one, but math? I gotta look into math, organic, inorganic. Yep. Peace out, YouTube. Peace out, Twitch. Peace out, Cake. Respect.